Welcome to M8307 Numerical Analysis class. In this lecture, we are going to introduce elementary matrices and their connection with elementary row operations. First, we will discuss interchanging two rows. In the augmented matrix below, interchanging second and third row is required to continue Gaussian elimination because we have 0 here and we need to interchange second row with the third row. So the conventional way, the way we have seen so far, is this way. So we basically say row number 2 will be replaced by row number 3, not replaced, interchanged by row number 3, okay? And then we perform the operation, okay? So this swapping operation is given by the matrix multiplication below. Another way to show it is this. So this is basically matrix product, okay? So the matrix on the left is known as the elementary matrix. Also, for this particular case, the interchanging rows, it is permutation matrix, okay? So to obtain this permutation matrix, we start with the suitable sized identity matrix. In this particular case, we can multiply this matrix from the left by 3 by 3 identity matrix only, not 4 by 4 or 2 by 2. Okay, so this means we are starting with 3 by 3 identity matrix and then interchange its rows that will be subject to swapping in the augmented matrix. Okay, so we first perform the interchanging on the identity matrix. This is, we started with the identity matrix and interchange the row number 2 with row number 3. So we obtain this permutation matrix on the left. Okay, so when we multiply this augmented matrix by the permutation matrix on the left, we obtain the same result. Okay, the inverse of a permutation matrix is equal to its transpose. This is a remark. So an example, this matrix corresponds to the interchange of row number 1 with row number 3, because we see this is, if we start with identity matrix, we can obtain this matrix by interchanging row number 1 with row number 3. Okay, so this is what it means in the row operation as well. Okay, also the inverse of this matrix will be the transpose of this matrix, and transpose of this matrix is the itself, so this one. So for this example, we have, if we consider the identity matrix, the first row and the second row is interchanged, and the third row and the fifth row is also interchanged, and the fourth row remain as is. So this means this matrix will correspond to the interchange of the first row with the second row and the fifth row with the third row. Okay, so also its inverse is the transpose. If we take the transpose of this matrix, we can obtain the same matrix, and this will be the inverse of this matrix. You can easily check that. So if you multiply this matrix by that matrix, you can you have to find the identity matrix of dimension 5 or order 5. Okay, next we consider the multiplying a row by a number. So let us multiply each entries in the second row of the following augmented matrix by 1/2. Okay, so the conventional way, the way we have seen so far is this. So we put an arrow and say we multiply the second row by 1/2. Okay, and then we perform the operation. This multiplication operation is also given by matrix multiplication, like that. So we have again an elementary matrix on the left, and then when we multiply the augmented matrix by this elementary matrix from the left, we can obtain the same result. Okay, so how can we find this elementary matrix? To obtain the elementary matrix on the left, this one, we start with the suitable sized identity matrix, again 3 by 3, and then replace its diagonal entry of the row number to be multiplied by the constant to be multiplied. The constant is 1/2 and row number is 2, so second row will be multiplied. So the second diagonal of the identity matrix is replaced by the number we are about to multiply. So this is 1/2. Okay, so we can obtain the elementary matrix on the left this way. Remark, the inverse of a diagonal matrix is obtained by replacing each element in the diagonal entry with its reciprocal, or the multiplicative inverse. Okay, so an example, this matrix will correspond to the multiplication of third row with the seventh row with 7. Okay, so if we multiply an augmented matrix with this matrix, that means we are basically multiplying the third row with 7. Also, its inverse is this one. We take the multiplicative inverse of the diagonal entries, and this will be 1, and the inverse of this will be 1, and 7 will be 1 over 7. Okay, another example. For this particular case, we started with an identity matrix, and the second diagonal entry is replaced by one third. So that means we are about to multiply the second row of the augmented matrix by one third, and here we have 5 on the fourth diagonal entry. So that means we are about to multiply the fourth row of the augmented matrix by 5. Okay, so this is what it means. And the inverse of this matrix can be found by taking the multiplicative inverses of diagonal entries. So this will be 1, and this will be 3, and here we have 1, this will be 1/5 and 1. Next, we will consider adding a multiple of a row to another row. Consider the following augmented matrix, and let us multiply the first row by 2 and the result to the second row. Okay, we will multiply the first row by 2. Okay, we will multiply this row by 2 and then add the result to the second row. So this is how we show this operation. Okay, r2 plus 2 r1, so twice r1 will be added to r2. The matrix multiplication way of the showing this operation is elementary matrix times the augmented matrix. Okay, so this elementary matrix will be can be found by starting with the suitable size identity matrix and then replace one of its zero entries with the number to be multiplied. In this particular case, we replace the zero entry here to be 2 because we are multiplying by 2. Okay, so how can we find which entry to be changed? Okay, so to that end, we have given a note here. The number of this entry, the row number of this entry, sorry, is the row number to be added only. Okay, which one will be added only? So this one will be, okay, R2 will be added. So the row number is 2. That means the row number of the entry which is about to change is 2. Okay, and the column number is the row number to be multiplied and then added. Okay, the which row will be multiplied and added? The row number 1. So number 1 will be the column number of this entry. That means we are changing the 0 at the position on the second row and first column. Okay, so this is also if you do quite a few examples with this operation, you can easily understand or intuitively see where it's going. So if you multiply this row by the matrix here, that means we are multiplying the first row, the entries on the first row, 2 times that, and so on. And we add the result to the second row. Okay, because we have 1 times that second row and 2 times this row will be written to the second row. Okay, so this is what we really get. Okay, now when we multiply this row by that, this will be 2 times 1 plus negative 2. Add it here. 2 times 1 plus 0, which is here, 2 times 0, which is, okay, let me see. No, 2 times 2 will be 4. And if we add here, that will be 1. And then 2 times 1 will be 2, plus 4 will be 6. And it's given here. So this operation is indeed the same with the one above. Okay, the inverse of such elementary matrix is obtained by replacing each off-diagonal entries by its additional inverse. Okay, so for example, this matrix corresponds to the addition of the third row with 7 times the second row, because we are in the row number 3. Okay, so this will be in the row number 3 and column number 2. So that means we are multiplying the second row with 7 and then adding to the third row. Okay, and also its inverse is here. So we replace the each off diagonal entries by its additional inverses. So these are all zeros, so additional inverses will be the same. And here we have 7, so the additional inverse will be negative 7. So this one, this matrix on the top corresponds to the addition of the third row with twice the second row, fourth row negative 3 times the second row, and the fourth row, sorry, the third row twice the second row, fourth row 3 times the second row, and the fifth row 4 times the second row. Okay, so we add this result to the corresponding row. Okay, so the inverse of this matrix is here. So we indeed replace 2 with negative 2 and 3 with 3. So negative 3 with 3, and 4 will be replaced by negative 4.